So question 10 says, determine whether the graph could be a graph of a polynomial function. If it could be, list the real zeros and state the least degree that the polynomial can have. One thing about a polynomial function is a polynomial function is continuous. So one thing we can say is a polynomial function is continuous. What that means is if I start here on the left, if I can trace the whole graph without picking up my pencil, that means it's continuous. And also if I draw this thing, it's a nice smooth curve, which is continuous. There's no breaks in the graph. So graphs that look like this are called polynomial functions. So yes, this is a polynomial function. Now the question is, what are its zeros? So we do see a zero at -4, and we do see a zero, looks like halfway between here. Looks like 2.5 probably. So that's going to be an estimation there. So 2.5 looks like that one. So that would be, what would 2.5 be as a fraction? So I don't know if it'll let me take 2.5 in. So let's go hit that enter and go math, change it to a fraction, 5/2. So the graph shows a polynomial function. We're seeing that. And the zeros are, looks like I'm seeing a -4 and a 5/2. So round to the nearest integer as needed. Oh, well, okay. Nearest integer, they don't want fractions there. So, whoa, that's going to be interesting over here. If I round to the nearest integer, then I'm going to have to say, looks like I would have to say 3 to the nearest one. So -4 and 3. So the least degree of the polynomial, notice that since there's 2 terms, the degree could be one more than that. So it can be a degree 3 because of that. So the number of terms also tells me that the degree is always going to be one more than the maximum number of terms. So we kind of see that going on there on that problem. All right. So it kind of concludes that one there.